So now that we've talked about volume of prisms and cylinders, we're going to talk about volumes of cones and pyramids, and they're very closely related. So by the time we get done with this, you should be able to apply those formulas for cones and pyramids. So remember that volume of a 3D figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. So for a cone and a pyramid, the formulas are very similar because remember for a prism and a cylinder, it was just base times height. A cone or a pyramid is 1/3 base times height. And in class we'll prove why it's 1/3. So you'll get some easy problems like this where it says find the volume of a rectangular pyramid with a length of 11, a width of 18, and a height of 23. So you have a rectangular pyramid, this all comes to a point here, and it tells you that the length is 11, the width is 18, and then the height of it is 23. So when we do the volume, 1/3 base times height, we're going to multiply 1/3 times the base, which is 11 times 18 because it's a rectangle, times the height of my pyramid, which is 23. And if we type this into our calculator, 11 times 18 times 23, and then multiply by 1/3, we end up with 1,518 meters cubed. So the only difference between this lesson and the lesson before it is you have to remember to multiply by 1/3. So I'm going to leave you this problem to do. It's another hexagonal pyramid, and I tell you the length of the sides, so remember you're eventually going to have to find the apothem. You know, this is 12. So remember you're always using tangent for this and to cut the 12 in half to make your triangle. And then there's another trick here. Because the formula is 1/3 base times height, the base is this hexagon. The height is equal to the apothem of the base. So once you find the apothem, that's what you're going to multiply by to find the height. So a cone is very similar. It is 1/3 base times height, but because the base is a circle, we tend to write it as 1/3 pi r squared h. And the steps are exactly the same. So if I give you a problem like this, find the volume of a cone with a radius of 7 centimeters and a height of 15, you can give your answers in both terms of pi, and then once we type it into the calculator. So remember that volume is 1/3 pi r squared, because that's our base, times our height. So 1/3 pi times the radius, which is 7, square that, and the height's 15. So we end up with 49 times 15, divide that by 3, so we end up with 245 pi centimeters cubed. And then if we want to, this tells us to multiply it by pi, so it's the same thing as 769.7 centimeters cubed. So this one's a little tougher. It asks you to find the volume of a cone with a base circumference of 25 pi and a height of that's 2 inches more than twice the radius. So let's do this one together. So remember, circumference is pi d or 2 pi r. Since we don't really care about the diameter, we're going to use 2 pi r. So if I tell you that the circumference, or like the perimeter, is this, we can quickly find the radius by solving for r. The pi's go away and we're left with 12.5 equals our radius. So we'll need this for our formula. And then it tells us that the height is 2 inches more than twice the radius. So we got to do 2 times r and then add 2 more. So that's 12.5 times 2, which is 25, and add 2, so the height is 27. So now we have everything we need to plug into our formula. Volume equals 1/3 pi r squared h. So 1/3 pi times our radius is 12.5, and we gotta square it, times the 27 that we just found. So 12.5 squared, and then we end up multiplying that by 27, and then multiplying that by 1/3. So in terms of pi, we end up with 1406, or if we multiply that by pi, we get about 4,417.9 centimeters cubed. So effects of changing dimensions. Remember, if you change something by A, the area changes by A squared, and the volume changes by A cubed. And it does not matter if it's a cone, a cylinder, a prism, a pyramid. If you're changing volume, it changes by that thing cubed. So the diameter and the height of the cone are both divided by 3, or we can say multiplied by 1/3. So the effect on the volume would be just to cube this. So you get 1 cubed over 3 cubed, or 1/27. So we can say the volume would be divided by 27, or multiplied by 1/27, whatever you want. So the last thing we got to talk about is composite figures when we add stuff together. And remember, with volume, it's way easier because you just take the volume of each thing, add them up, and you're good to go. There's no subtracting here. So find the volume of this, round to the nearest tenth. So we have 2 cones and then a cylinder in the middle. So it doesn't really matter which one you find first, but let's find cone number 1 first. So cone number 1, we'll call this guy up here. And they tell us that this entire distance here is 70, and this distance here is 35. So that tells me that the height of my cone here is 70 minus 35, or 35 centimeters. So remember, for volume of a cone, it's 1/3 pi r squared h. So let's plug stuff in. We know the radius is 21, and we got to square that, and then multiply by the height that we just found, which was 35. Because it says to round to the nearest tenth, I'm just going to multiply the pi in there with it. So 21 squared times 35 divided by 3, and then multiply by pi. So the volume of cone number 1 is about 16,163.5 centimeters cubed. Now let's find the next shape. Let's find the cylinder. Remember from yesterday that a cylinder's volume is base times height. Because the base is a circle, it's pi r squared h. So it's exactly the same thing as a cone, but we're not cutting it into thirds. So we have pi times the radius is exactly the same. It's at 21. And then the height of this, we said, had to be 35. So we do 21 squared, multiply by 35, and then multiply by pi. And we end up with 48,490.5 centimeters cubed. Now, the last one we got to do is cone number 2. What's on the bottom? So 1/3 pi r squared h. 1/3 times pi. The radius is nice and the same for all of these. And then the height of this one, they tell us, is 40. So type it into our calculator. And you should end up with 18,472.6 centimeters cubed. And now, because this is a composite figure, I want to know the total. So all we got to do is add these three things up. So the 18,000, the 48,409.5, and the 16,163.5 gives me 83,045.6 centimeters cubed. And that is our answer. So I'm going to leave one of these for you to do, and we can go over it in class. This is a prism with a pyramid cut out of it. So instead of adding for this one, you'll have to subtract. So you should be able to apply those two volume formulas. They're basically the same as before, except you multiply it by a third. Make sure you write down any questions you have, and we can go over them together. Enjoy your night.